Today we are solving systems of equations with elimination. Just like the name suggests, we eliminate one variable by adding the two equations together. Our steps. Step 1, we combine the two equations so that one variable cancels out. In order to do this, you may have a situation where you need to multiply all the terms of one or both equations by a common factor to eliminate the variable. Our second step is to solve for the remaining variable. After that, we will substitute the value of the solved variable into one of the original equations and solve for the remaining variable. So after our first step, we fall into how the substitution method works from there. Now, let's go through an example to show what I'm talking about. In order to do step 1 of combining two equations for one variable, we must first decide what variable we want to solve for. In this case, for our situation, we have opposite values for our y, so that's the easiest one to cancel out. So we're going to eliminate the y variable. So when we do this, if I can click on the right spot, in this case, I don't need to multiply them by anything. They're going to cancel out just by adding together. So I can go over into the next box. In our next column, we write the two equations that we are going to combine. If I can type everything out properly. X plus 3y equals negative 2. And we're not multiplying either one, so we just rewrite them exactly the way they are. X minus 3y equals 16. Now, when we add these together, we just add the like terms on each side of the equation. We still follow that rule. So in this case, x plus x is 2x. 3y plus a negative 3y is 0. 0y cancels out. And then we have equals negative 2 plus 16, which is a positive 14. From here, once we eliminate one of the variables, we're just left with x. We want to solve. We have one step, get rid of the 2 by division on both sides, which leaves us with x equals 7. 14 divided by 2 is 7. So in this case, we already found one of our values. Now it does not matter which equation we choose because we already used both of them in this step. So I'm going to use the first one. Rewrite the equation. Show that I'm substituting in the value. So instead of the x, I'm going to use the value 7. I subtract my constant. Leaves me with 3y equals negative 2 minus 7 is a negative 9. And then my last step is to divide by the coefficient, which leaves me with y equals negative 9 divided by 3 is a negative 3. So in this case, we found the value for both our x and our y. So we can write out our solution with our x being 7 and our y being -3. Now in comparison to the substitution method, this normally takes a lot less work, especially on problems like this where the variables are on the same side. I don't have to do the first step of moving a variable to the other side or any other factoring depending on the equations. It's not always the case. Sometimes when you have to multiply one of the equations by a constant in order to eliminate them. If we were to add these, 2x and x would give us 3x, and then our -y and 3y would give us positive 2y. It wouldn't cancel out a variable. In these situations, you still want to pick which one you're going to eliminate, and we're going to have to multiply an entire equation by a value. For this one, I see that my y and 3y are opposite signs, so that's going to be an easy one, and I only need to multiply one row. So I'm going to use or eliminate my y variable. You could choose to do the x variable if you would like. You're going to do a similar process. Now with this, you want to show what you are multiplying by. In order to get the opposite value of a positive 3y, I need to multiply y by 3. And in order to do that, I need to multiply the entire row by 3. Or entire equation, sorry. So the equation originally was 2x minus y equals 4. What I'm going to do is multiply this. I'm going to multiply this by 3. That is the factor that will help us eliminate our y variable. And just to show that I'm not changing the other equation, I rewrite it out to just the way it was. Now let's get that the right color. So I'm writing out both so you know that I am only changing the top one, my first equation. Now I'm not changing the second equation. If I distribute this properly, I have 3 times 2x, which is 6x. 3 times the -y gives us our -3y, the whole reason why we're doing it. And this equals 3 times 4, which is 12. So as you can see, we now have opposite symbols of the same value, 3. When I add these two equations together, just getting that extra drawing in there so you can see what I'm talking about. 6x plus x is 7x. -3y plus 3y is 0y. It cancels out. 12 plus 16 is 28. Yet again, we have one step to deal with. We have to divide both sides by 7. This gives me x equals 4. Now from here, it's kind of a rinse and repeat. We go to our last one. I can choose whichever equation I want from the originals. I'm going to choose the second equation. I'm going to, in this case, replace the x with the value 4. Oops, didn't mean to have it changed. There we go. Subtract 4 from both sides. and then I divide by the coefficient. So this last part is simply substituting in a value and then solving for the remaining variable. With this, I can type in my solution. My solution being x value 4, y value 4. Now the last major equation that I'm going to do with y'all is whenever you have to multiply both equations. If you look right here, there's no multiple of 3 that could equal 5. There's no multiple of 2 that would equal 5 as well. So I need to change both of them with their least common factor. Least common multiple. So in this case, it's a matter of choosing which variable you want to solve or eliminate. I've been in the process of eliminating y, so I might as well stick with it. In order to do that, their least common multiple is 10. So in order to do that, I need to multiply the top row by 5. If I can get the right font. So I'm going to multiply by 5. Now, as of right now, if I were to just multiply by a positive number on the second row, I would get another negative. It would not cancel out. So I need to multiply by a negative value. In order to get 10, I need to multiply by a negative 2. Then I rewrite the equation. So this would be one, oh, didn't even scroll down all the way. So this would be one of the longer process when you have to multiply both equations in order to do this. From here, you'd move over to the next section. You would distribute the factor. 5 times 3y is 15, or I'm sorry, 5 times 3x is 15x. 5 times negative 2y is a negative 10y. And then 5 times 2 is 10. My second equation, negative 2 times 5x is negative 10x. Negative 2 times a negative 5y is a positive 10y. The whole reason why we're doing this, so we can cancel those out. And then negative 2 times a positive 10 is a negative 20. Let's line these up a little bit better. So from here, we can cancel out our variables. Maybe if I show that we're adding. $15x plus a negative 10x is 5x. Same as 15 minus 10. Our negative 10y plus 10y cancels out. And our 10 plus a negative 20 would be a negative 10. Last step is divide both sides by 5. It leaves us with x equals a negative 2. So now we have our value. We can take one of our equations, does not matter which one, since we already used both. In this case, I'm replacing x yet again with a negative 2 is being multiplied, so I want to make sure it's inside parentheses. This still shows that I'm multiplying the 3, just like I was in the original. You simplify. In order to get rid of negative 6, I add 6 to both sides. So 2 plus 6 is 8. And then I would divide by the negative 2 on both sides, would give me y equals, keeping it lowercase, y equals negative 4. Now that I have both variable values, I can type in my solution. If y'all heard me snapping, that was because my cat was trying to tear up my couch. My solution being x value negative 2, y value negative 4. Now, in situations where you could have no solution or infinite solutions, in this case, this problem right here, are systems of equations where we have negative 6 equals x minus y and 36 equals 2x minus 2y. If I were to multiply the top row, the top equation by a negative 2, it would simplify out. My goal was to eliminate the y, but in this process, let me draw my plus sign. Keep the consistency looking good. As good as my crooked plus sign can look. (12 plus 36 is 48. Negative 2x plus 2x is 0. 2y plus negative 2y is also 0. I can't leave one expression blank, so I place the 0 into the equation. It's the only time you will see the 0, or you're forced to use the 0, is whenever the entire expression has a value of 0. In this case, this is a false statement. Get that full word out. So this is no solution. Just like in substitution, if our variable cancels out and we're left with a false statement, it leads to no solution. There's no value for x and y that would be the same for both equations, sorry. Same thing for the next one. Gave us another situation where when I try to eliminate for a variable, which by the way, I should have declared what variable I was solving for, or eliminating. It's all about the consistency. (3x plus a negative 3x is 0. 6y plus negative 6y is also 0. I cannot leave an expression blank, so I put the 0 in there. Negative 3 plus 3 is also 0. When you get 0 equals 0, this is a true statement. For consistency purposes, capitalize that one up there. This is a true statement. On a true statement, the opposite happens. You get infinite solutions. So in this case, same as substitution method. If my statement is true, infinite solutions. If my statement is false, I get no solutions. Also similar to the substitution method, once I find the value of one variable, I can go back and plug it into an original equation and find my remaining variable. The process to get the first variable value is different, however. We combined our two equations. Look at the original equation. We combine our two equations in order to leave us with one variable in the equation. And that is the elimination method.